Welcome, boys and girls. What I'm going to show you here from lesson 2.7 is the essential question, which is when solving division problems, when do you write the remainder as a fraction? Really, in this lesson, we need to take a look at the remainder, and we need to look at a few different ways that a remainder can be interpreted in a word problem. So here are some ways that we're going to look at and see how these remainders are actually used. Sometimes we could take the remainder and, yes, sometimes we could write it as a fraction. And we're going to look at a problem that we would have to do that for. Sometimes we're going to take a look at that remainder and we're going to add 1 to the quotient. Another way we could use a remainder is we can use just the remainder as our answer, or sometimes we can just ignore the remainder and not use it at all. These are typically the four main ways that we would interpret a remainder, and we're going to look at some examples to show you that. Alright, so let's take a look at this example here. It says a glass can hold 10 ounces. How many full glasses can be poured from a 32-ounce pitcher of lemonade? So here's my pitcher of lemonade. There's 32 ounces in there. Here's a glass, okay, and inside that glass, the glass can hold 10 ounces. Alright, so I want to figure out how many full glasses can be poured from this 32-ounce pitcher of lemonade. And I know each glass can hold 10 ounces. So essentially what I'm doing here is I'm figuring out how many groups of 10 I could make out of this 32. Okay, so if I was dividing this, figuring out how many groups of 10 I could make from 32, I would divide, and I know from my basic facts that I would be able to make 3 full groups of 10, and that would give me a remainder of 2. Now, the question is asking how many full glasses can be poured. Well, I know from dividing that I can make 3 glasses that contain 10 ounces each. If I had 3 glasses that contained 10 ounces each, I would have used 30 ounces from my pitcher over here that had 32 ounces. If I used 30 ounces of the 32 ounces that were in the pitcher, that leaves me the 2 ounces that are left over. The key part to this question here is how many full glasses can be poured. If I have 2 ounces left, yes, I could make another glass, but that other glass would only contain 2 ounces. It would not be completely full. So the answer to the question, how many full glasses can be poured? 3 full glasses can be poured. In this case, we don't need the remainder in any part of this answer here. So we're going to ignore that remainder because we know that 3 full glasses can be poured. We don't need that remainder to help us out. We don't need to use it in this case at all. So that would be a situation where you would actually ignore the remainder. Now this is going to be a different way that we're going to be able to use the remainder. It says how many tables are needed to seat 10 people if 4 people can be seated at each table. So one table can hold 4 people. We know that we have 10 people. So what we're doing is essentially figuring out how many groups of 4 we can make from the 10 people. Because these tables seat 4 people, we want to figure out how many groups of 4 we can make from the 10 people that are there. So again, numbers are pretty basic to start out just so we understand the concept. If we take the 10 divided by 4, we would get 2, and we would get 2 left over. So, well, what does this mean? This means that with 4 people at each table, and 10 total people, we could make 2 full tables of 4. Because what's going to happen is, with those two full tables of 4, that means that there would be 8 total people at those tables. We started out with 10 total people here. This 2 down here, that's the remainder. That's the remaining people that are left. So far, if I have two tables of 4, that's 8 people, I have 2 people that are left over here. Now the question is asking how many tables are needed to seat 10 people if 4 people can be seated at each table. Well, right at these 2 tables right here, there are a total of 8 people, but we need to include these 2 people that are left over. So what we need to do is we need to add one more table, and there's going to be 2 people at that table. So the final answer of how many tables are needed, we're going to need the 3 tables, because 2 of the tables will have 4, one of the tables will have the 2 people that are left over. All right, so the final answer is actually 3 tables. So in this instance, we would be using this remainder to add 1 to the quotient. There's also another way we could use the remainder. Here's another example. It says Mr. Johnson wants to hand out 133 award certificates to students in his school. Certificates come in packages of 12. How many packages does he need? Well, he wants to hand out 133 of them. All right. In one of these packages, there is 12. There are 12 certificates. So what we need to do is we need to figure out how many groups of 12 he could get out of 133, meaning how many packages he could get if 12 come in each package and he needs 133 total. So this is dividing 133 divided by 12. How many groups of 12 are in that 133? If we were dividing this, okay, we know that 13 tens divided into 12 groups would be 1 in each group. We would have 1 left over. At this point we bring down, and it actually turns out to be the same as the first step. We have 1 remaining. We would get 11 remainder 1. Now, what this 11 represents, the 11 packages of 12 certificates that Mr. Johnson can get. So if he had 11 packages and each package contains 12 certificates here, we have 11 packages that contain 12 certificates. That means that would be 132 certificates that are in these total of 11 packages. But the problem is here, we have 1 certificate that would be left over. And the reason that's a problem is that 11 groups of 12 gets him the 132 certificates, but he doesn't want 132 certificates. He wants 133 certificates. All right, so he needs 1 extra certificate. So what does he need to do? He needs to get 1 extra package here. 11 packages is not going to be enough, so he's actually going to have to order another package. So he's going to have to add 1 on to that 11 packages that he has and get another package, and that would give him 12 total packages that he would need to get those 133 award certificates. So this is similar to the last one where we would have to use that quotient and add 1 to use the remainder and add 1 to our quotient. And here's one final example. We have Erin has 87 ounces of trail mix. She puts an equal number of ounces in each of 12 bags. So she's going to have a total of 12 bags here. And she has a total of 87 ounces of the trail mix. So she needs to take that 87 ounces and she needs to divide it into 12 groups. Okay, so if we were doing our math, we were doing 87 divided by 12. What we would be able to do is we would take that 87 divided by 12, and we would get 84 with a remainder of 3. Now, what this means is if we had 87 ounces and we put them equally into 12 bags, there would be at least 7 ounces that we would be able to put in each of these bags. So there would be 7 ounces in this bag, 7 ounces in each of these bags. But we could actually take what's remaining and also include it. We have 3 ounces that are remaining, that are left over. Okay. What we could do with those 3 ounces that are remaining, we could take those 3 ounces and we could divide them by the 12 bags, or into the 12 bags. All right. So what we would do if we're taking whatever's left over and dividing it into the divisor, what we're doing in that case is we're writing that remainder as a fraction. So we would take that the numerator, the remainder, and we would write it as the numerator, and we would take the divisor and we would write that as the denominator. And what we're left with is a fraction. So in each bag, yeah, there would be 7 ounces, but there would also be 3/12 that would be added to it. So each bag would actually contain a total of 7 3/12 ounces. And again, the reason that is because we have these 3 ounces that are left, and we're dividing these 3 ounces into these 12 bags. 3 divided by 12 is written like a fraction as you see it right here, and it's written as 3/12. So we combine that with the whole number, which was 7, and our answer would be 7 3/12. We could also write that 3/12 in simplest form, and we would, if we were writing that fraction part in simplest form, the greatest common factor is 3. We divide the numerator by 3 and the denominator by 3, and we get 1/4. So it could also be written as 7 1/4.